Hello everyone and welcome. My name is Arturo Lopez and I'll be your guide today with the small tutorial we have prepared for you today about RecordBase station and cross-triggering. Why do we want to do some cross-triggering between our devices? In this case, we're going to be using the Tesla 4000 and the RecordBase station system, which is a software that automates the recollection of the records that get created within our DFRs, or even with the relays that we also have. Okay, then the question would be, why would I want to automate the recollection of said records? Well, let's say we have a power system with 10 DFRs Tesla 4000s installed, and we have one of them is creating a record due to a trigger, let's say low magnitude in voltage and also high current in magnitude. You can put this as an example in a line that has a fault from phase to ground, for example. But you also want to know the information from the other recorders that you have. So RecordBase station is going to act as a server that's going to create a cross-triggering between all your devices, so they get time-stamped at the same time that the first Tesla created the record, and then you'll have the information from all the other units available to you. Okay, we're gonna talk a little bit about RecordBase station first, and how it's composed of different modules that they're going to serve us to either configure the units, monitor the system, and also our database that's going to keep all the records together. Okay, so let me show you our way around RecordBase station. First of all, we're gonna have 4 different modules. The first one is called RecordBase System Manager, which is the one that is going to be running on the background of your PC or laptop or server, and it's going to keep the system running. Basically, we just have to give it one click and it's going to do everything by itself. Then we have RecordBase Collector. RecordBase Collector is the part of the software or module that we're gonna be adding all of the units into our system. In this case, I'm gonna be using 2 Tesla 4000s. One is called CS-IP25 and the other is Tesla IP26. These are set up in a VPN that we're gonna be working with. Let me do it from scratch, and we're gonna click on New. And if you've used Tesla Control Panel before, it's going to look very similar to you, which is basically the same way we're gonna be extracting information from the unit. In this case, I'm gonna be adding a new unit that we're not gonna be working with, but it's just for the demonstration purposes. Click OK, and as you can see, the unit ID and the location, etc., it says unknown. We go into Edit, and then we're gonna click Get Information from ID. We wait a little bit, and it's going to download the information from the said unit. In this case, it didn't give me any unit ID or name or number, because the unit doesn't have it configured. But it did give me the serial number of the unit. I click OK, and of course, since it doesn't have a name per se in the unit, then it's not going to appear in here. Okay, so this is how we are going to be adding the new units into our system. We go into Delete. And after we have them ready in our system, we're going to have to do something else to do the cross-triggering group. We go into Edit, and here we have a section that says Cross-Trigger Group, and we're going to give it a name. In this case, I'm putting the name Cross, just for reference. It can be Group Trigger, Cross-Triggering Group, whatever you want it to be. We click OK. We do the same for the other unit too. This way, we're gonna have the cross-triggering group that's going to be working together. We can have different cross-triggering groups. For example, if out of 10 Teslas we have in the system, we can have 5 in a single group and the other 5 in another group. This is to make matters easier for you when you're trying to organize all the Teslas in your system, because we have to remember that RecordBase station allows us to have up to 400 units in the system. Imagine having basically 400 Teslas working together creating records. It would be madness. So this way you're going to be able to keep them all together and neat and tidy, so you can have them in different groups, let's say by different power plants, substations, etc. Alright, now we have something else that says collection rules. Here we're gonna be enable the Tesla to act automatically. We can, for example, say 7 days a week, and at a certain time of the day, and during that day or time period, we're gonna have different calls and how long the calls are gonna be. In this case, I'm using just a single poll. It would be a single call, and under each call, how many records I'm going to be transferring. In this case, we can transfer from 1 to basically 999 records, and also the time limit of the set transfer session of the records. Let's say we're gonna be downloading 200 records, and we're just gonna give it maybe 1 hour. And if in this hour it only downloaded 180 records, then it's going to wait until the next session, which we can also set up in here, and to download the other 20 remaining records that we had left. Also, we're gonna have some record handling if we're gonna be transferring the newest records first, transferring the oldest first, and also we have the option to delete remote records after they've been transferred. Personally, I don't like to keep I like to keep this checkbox off, because that way we have sort of a redundant backup of the record database. We're gonna have them in RecordBase Utilization Administrator, and also in each recorder, in this case Tesla 4000. We can also convert to CompTrade after the transfer to either ASCII or binary, and also you can export in secondary or primary quantities. And last but not least, we have the incoming calls, which is the section we're most interested right now. Here we're gonna have the enable cross-triggering of other IDs, and also start the collection immediately after cross-triggering. So we're gonna set both of those checkboxes for each unit, and this way we're gonna be done with the RecordBase collector. Now we're gonna go into the RecordBase monitor. Here, well, we're gonna have both of our units in this list, and we're gonna be able to see how the system is working. If it's communicating within one of the other units, if it's downloading any record. Here we're gonna have the activity log, where it's going to say you added some units, you modified the collection rules, etc. And you're gonna be able to see all the information that is happening in the system. Then we have diagnostics log, where it's a little bit more difficult to read, but you're gonna be able to see that it's fetching records and also downloading them. For example, here I was downloading a record a little while ago. It says fetching and a series of numbers and letters. Then what time was the trigger of the record, and that it's a 1 out of 93 records over FTP port 21. So that way I know that it's collecting the records. So this is going to be a very handy tool, so we know that the system is working properly. We're gonna leave this aside, and we're gonna leave RecordBase Administrator for last. So that's going to be our database where all the records are going to be stored. Now let's go into the Tesla control panel, and also let's open up our relay tested software. Right now I'm going to be connecting into Tesla IP25, which is the one that's going to be receiving the trigger from the double, and then it's going to make the cross trigger into Tesla IP26. Okay, service as usual. Alright, so now we're gonna go into the communications tab. Here is very important because this is where we're going to tell the Tesla where it's going to communicate. Alright, so after you have set up your Ethernet communications parameters, we go into FTP. We have to enable it. RecordBase Central Station, or let's say RBCS from now on to keep it short. RBCS needs FTP communication enabled, so keep this in mind, because if you don't have any enabled, it's going to give you an error message that you need to enable FTP. Thankfully, it gives you the error message, because there are some other instances in some other things that in life that, well, you get the error, but you don't get what the problem is at in the end. Now let's go into the RBCS tab. Here we're gonna set up the IP address of our PC. Pardon me, I was gonna say the unit, but no. This is the IP address of our computer, PC or server, laptop, whatever device you're using that's going to be collecting the records. In this case, this is the IP address of my laptop. And now we have notify RBCS on creation of new recording if priority is at least. We have 0 any records and 3 max priority. I'm gonna show you in a little moment when we go into the analog input and all the record configuration we have in the Tesla, that we can have give priority to each type of trigger that we have inside each channel. Alright, so now we close it. And also one more thing, let's go into time. It is very important that we have RecordBase sync, because we're gonna be having a timestamp in the record. And that timestamp is going to be sent to all the other Teslas, so they have the same timestamp to create the record. The Tesla 4000 has a memory buffer with fault records up to 8 seconds behind as a pre-fault time, and swing records, they have a pre-fault time of up to 15 minutes. This means that with the buffer, we can align the timestamp of all the other units so they have exactly the same timestamp of the record creation, so we can align them in time and have all the information exactly at the same time. But it has to be RecordBase. Yeah, that's a requirement for RBCS to work properly. Now we go into settings. Let's go into present settings to download the settings. And now I have here a DC channel. It's a DC channel on channel number 9. And I'm going to create a record using a high magnitude trigger of 16 milliamps. First, I have to enable the channel, of course. Well, no, the trigger of the channel, because this is channel number 9. So this is going to be the trigger of high magnitude and DC current. I'm going to be creating a fault record, or if I wanted to create a combined record, and I would have to also select the other checkbox of swing. What's the difference between fault record and swings? Fault are the transient records, which are of a high speed, from 8 seconds to the back and up to 60 seconds up front of post-fault time. And also as with a 32 samples per cycle speed up to a 384 samples per cycle speed. Now the swing record is a slow record of 1 sample per cycle, and this is going to give us some time of up to 15 minutes of pre-fault time and up to 30 minutes of post-fault time. And if we wanted both, then to create a combined record, then we select both checkboxes. I'm just gonna select the fault checkbox. Log is to send it over to the events log screen, and here notify is an important column. Here we're gonna be notifying our RBCS that the record is being created, and that the server needs to listen up to the unit and download its said record. And then we have the priority that I was talking to you a little while ago, where 0 is any record, and if depending on the priority we give it, we might have instances where we have different records being created at the time. So we need to be very careful how we're going to be giving the priority, so they can basically keep track of all the things we want to send over to the server. In the end, all the records are going to be sent over to the server. However, if we want to give them a priority, then this is where it's going to be. Hey, but you may be wondering, what is this cross-triggering column we have here? Well, this is a different type of cross-triggering, if we could say that. This is going to be a local cross-trigger. And if you see that the Tesla has up to 8 output contacts, then number 4 is going to be designated for a cross-triggering action. If I were to select this checkbox, then the output contact number 4 is going to be closing, and then we can use that as a digital output to send it over to somewhere else. Let's say another Tesla 4000, where we're gonna use it as a digital input to create a record. However, the downside of this, it's going to be that it's not going to have the same timestamp as if we were doing the cross-triggering with the RBCS. Why? Because we are sending the signal over as an output contact, through copper, and then we depend on the time that the output contact gets close in this Tesla, the time it takes to travel to the other, and then when it gets processed in the other Tesla. We're not gonna have the same timestamp, so just keep it in mind if you wanna use it also to create local records in daisy chain style. All right, then now it's configured. Let's close this. Since it was already saved, then I'm not gonna be doing any changes. And let's go into the metering screen. Let's give it some zoom because I can't see a thing, and probably neither can you. All right, now I am in secondary values. Apparently, I'm connected right now to my double. All right, let's verify the connection. Just to make sure everything's working. Okay, it's connected. All right, now I set my DC channel. Let's connect to it. And let's keep a close eye here on the Tesla 4000 screen, and also here in the RecordBase monitor, because this is where we're gonna see the cross-triggering action. All right, let's system out on. All right, there we go. It changed. And here you can see that the Tesla IP26 has already received the cross-triggering action. That of course is coming from the Tesla IP25. Let's remember that we're connected right now and working with the IP25. Okay, that's good. I'm gonna minimize this. Let's go into activity log. Why do we have cross-trigger accepted from the record that we just created at 22:32 minutes? Let's go into the event screen. 22:32:06 and 800 milliseconds, and here it is, up to the seconds, the number seconds. All right, it's doing the recollection. Now it has already collected the record from Tesla IP26. Now it's going to collect the one from IP25. That was the first one to be created. Now let's, as a side note, keep in mind that when we are doing cross-triggering with RBCS, all the other records that get created from the cross-triggering are going to be in the swing factor. Right? They're going to be in the swing type of record, the slow record that I mentioned a while ago, and this is due to the sample rate that it gets to be handled, and all the information that needs to be processed with all of the Teslas in the system. So just keep in mind that in this case I'm going to have a fault record in IP25 and a swing record in IP26. But again, it's a very useful tool to have information from everything in your system. All right, collection successful, IP25. Now let's go into our RecordBase system, RecordBase administrator. Man, all these modules are gonna drive me crazy. All right, here we have the record that we created first, which was at 22:32:06 and 800 milliseconds. And now the other record on Tesla IP26 with the same stamp, thanks that both of them have an IRB time sync. And you can see that here is the DC high magnitude trigger, and then here in the event screen we have a swing cross trigger record via RBCS, and also received RBCS swing trigger for the under UTC time. And well, that's basically how we're gonna get the triggers, and the records all the records gets downloaded. And with RecordBase Administrator, we're gonna be able to basically just open up the record. And let's see the analog. It's not this one. This is IP26. Oh yeah, I messed it up. Tesla IP25. Here the DC channel, where it had a little bit of noise. Well, basically the whole signal has noise. Excuse me for that. And how we created the record, ramping up to 20 milliamps. And also in here in the RecordBase Administrator, you can do filtering of all the units that you have in your system. You can also use for the release we have from ERL, let's say T Pro, L Pro, F Pro, B Pro, etc. Or if you only want one in particular, let's say F Pro, or in this case, since I only have Tesla records, it's going to be that. And we can select all the other units we have already in the system. We can select only Tesla IP26 or IP25. And also filter out within a time frame, let's say in the past 5 years, months, weeks, days, hours, or minutes. or between a certain period of time. Let's say we want all the records from February 7th up to 8th, then at a certain hour, then we can do that. Well, thank you everyone. This was a very brief tutorial on how to create cross-circuit records with RBCS and Tesla 4000 system. I hope you enjoyed the video, and if you have any more questions, comments, or doubts, please comment below, or also you can reach us at the mailbox of support@erlphase.com. And well, once again, my name is Arturo Lopez, and I was very happy to be able to assist you here today, and I'll see you next time. Thank you.